All right, welcome back to my channel. And today we're going to go through some math problems. So let's get into it. All right, so we are going through this point slope formula right here. And so we talked a lot about point slope before in the previous video or on our previous day. So the point slope form looks like this. There's other versions of it, but this one is kind of like the one that I like to use. The reason why it's called point slope form is because they give you the point and they give you the slope, right? So if you give me those two ingredients, then I can build you an equation. Okay, those are the two ingredients that I need. And then over here, it says, write the equation of the line shown in this graph using this method, right? So the very first thing you say, hey, Ms. Johnson, they give me 2 points. Which point do you want me to use? I don't know, whichever point you want to use. Ms. Johnson, I don't think they gave me the slope. They did give you the slope. Where do you see the slope here? Excuse me. Where do you see the slope here? Anybody see it? Oh, they did give me the slope. My bad. Where do you see it? Very good. There's two ways that you could have said, I see it, Ms. Johnson. So either one, you saw it using the formula, and the formula for slope, in case you forgot, looks like this. M is the letter for slope. It's y2 minus y1 over x2 minus x1. This is fancy for saying rise over run. How much did you go up versus how much did you go over? So I like finding the slope on a graph because that's just better for me. So I start at the bottom point and I count how many times did I go up. Elevators, right? So I went up 2 floors and then I count how many times did I go over. And I go 1, 2, 3, 4, 5, 6, 7. So here you're counting blocks, not tick marks. So 1, 2, 3, 4, 5, 6, 7. So my slope, if it's rise over run, so rise over run is going to be, my rise number is 2 and my run number is 7. My rise number, I went up 2, right 7. And up means positive and right means positive. So that's my slope. Okay, you would have gotten the same exact thing had you calculated it using the formula. But if you give me a picture versus a formula, I'm always going to use the picture. Okay, because counting for me is a lot easier than calculating, right? So I'm going to take this and any one of my points and I'm going to plug it into my formula and then I'm done. So can you do that for me really quickly? Can you pause the video, give me an equation, and let me know what you think? So this is pencil to paper time, guys. Go. All right. So if you were able to plug all this in, because so one of my favorite teachers from high school used to call this problem a plug and chug. So all you do is you're just plugging in information, and then the chugging is like you like calculating or doing whatever. But in reality, you can leave it exactly as you just plugged in. So I'm going to take my slope, which is this guy here, and I'm going to put him in for M, right? And then I'm going to choose a point. Now, if you know Miss Johnson, right, which point would she use? 1, 1 or 8, 3? Yeah, I'd use 1, 1. So Miss Johnson tends to use numbers that are smaller, that are not negative, that are not fractions, in case she needs to simplify. So I'm going to take my X and plug it in for my X. And I'm going to take my Y and plug it in for my Y. Okay. And some of you are saying, hey, Ms. Johnson, how come this one has X1 and this is just regular X? And I'll just say it like this, like X1, Y1 means that X and that Y, like a very specific X and very specific Y, versus this X and this Y are like the general X and the general Y, like not person general, but like in general. Does that make sense? So I'm going to take all this and then I'm just going to plug it in and then I'm done. So let me plug in. So first I always copy the equation. Y equals M parentheses X minus X1 plus Y1. And the reason why I write it again is because the more I write it, the more it goes into my brain, right? And I want it to go into my brain so I don't have to waste time to look it up later because it's now just in my brain. All right, so then I just need to put all my blanks in. So I like to leave all these blanks here because then I have to fill in that guy, and that guy, right? And so like I said, 2/7 goes there. My X and my X go there and there. Now, some people, I will say this right now, some people are like, no, you have to multiply this out and then add and simplify. But do you see how here it says write the equation of the line shown? Is this the equation of the line shown? Yes. Okay. Yeah. Did it tell you to write it in a specific form? No. It'd be very different if they said something like this. Write the equation of the line in slope-intercept form, the y equals mx plus b guy, right? But it didn't. It just says write an equation, write the equation. So is this the equation? Yes. So I'm done. Any questions for this? Okay, which part of this is the question that I like to say, which part of this is really difficult? No, seriously. Yeah, I think for me, the most difficult part is like remembering this equation, right? Because once I remember this equation, then I'm like, oh, the slope goes here. Where's my slope? Oh, it's right there. What goes right there? Oh, that's just an X and that's just a Y, right? So for me, the hardest part is remembering this formula. But once I have it down, then it's a matter of just plugging in. Okay. Counting the slope. Yep. Just remember that you guys have been finding slopes since probably 7th or 8th grade. Right. And the reason why I say that is not so that you can be like, oh man, I've been using this since 8th grade. It's more because I want you to know that we build, like math builds on stuff, right? What I'm teaching right now in integrated 3 is literally the next level to what I'm teaching in integrated 2, right? So yeah, it definitely connects, which is, right? This is why math is so different than any other subject for me anyway. All right, it says use this method to write the equation of the line with slope -3 that contains the point -1, -5. And you're like, wait, what? You want me to do that again, Miss Johnson? Yes. Yes. Okay, so you just want me to do the same thing? Yes. So, Miss Johnson, there's no real difference here. Well, kind of. There's a very small difference. So, but I want you to practice. So, how do you get better at something? You do it again and again. Okay, so I'm going to pause this. I want pencil to paper. I want you to do this right here and give me an equation. Do you need to write all this work? No, you can just give me an equation. Okay, go ahead and pause and give yourself some time to do this. All right, so we're going to just continue. I don't know why I have this thing out still. Wow, that's all right. So when I am using this equation, again, I'm going to use this equation over and over again. I literally write it over and over again until it goes into my brain. And what I try to do is I don't look at the equation and I write it from memory. And then I check really quick, did I copy it right? Did I write it correctly? So I write it from memory and I'm like, hey, and I kind of like match it up oh, look, I did it right. Yay. Right. So then what I'm going to do is I'm going to start filling in my blanks. So I need an M, I need an X1, and I need a Y1. So where does this slope number go? Where does the -3 go? Yeah, it goes in the M spot. Very good. Right? Very good. Where does this -1 go? Where does this -1 go? Yeah, it's the X number. Right? And where does this Y go? In the Y spot. Very good. I should have said the -5. Where does the -5 go? And then I'm just going to clean it up, right? So then this turns into, I'm going to write Y equals -3 parentheses X plus 1 plus -5. Oops, let's just put -5. So there's my final equation. And what I like to do is I like to check my answer. Couple different ways that you can check it. I haven't really talked about how to check it, so I want to see your ideas. What are your ideas? How would I check my answer? So yeah, one way, very good. Use the equation and plug in your information to see if it's right. Very good. The other way is to use Desmos. Very good. So let me show you both ways so that you guys are confident in both ways. So the first way is if you're not allowed to use a calculator, which in my class you are, I would plug in the point -1, -5 into my X and my Y and see if it turns out to be a true statement, right? So I'm going to plug in -5 for X, Y, equals to -3 parentheses, -1 plus 1 minus 5. So give it a second. For some reason, it is on the slow side. So this plus one, someone asked in the chat, hey, Ms. Johnson, where did this +1 come from? So X minus -1 turns into X plus 1, right? Because minusing a negative is really like adding a positive, right? The other place that I want you to focus is this minus here that is in the equation X minus X1 is not that minus. They're separate. So I have to subtract off that X. If the X happens to be negative, then it's going to be adding. So I plugged in the point that they gave me, -1, -5. and I used algebra to figure out if I'm using algebra to figure out if this is true. So here I'm like, okay, well, Ms. Johnson, what do you want me to do? I just want you to see, is there anything here you can simplify? Yeah, that -1 plus 1. Very good. What is -1 plus 1? Very good. It's a 0, right? And -3 times 0 is 0, right? So is this a true statement? Is -5 equal to -5? I'm asking a question. Is -5 equal to -5? And you guys are like, yeah. So here, Miss Johnson, she's super happy because look, she wrote a good equation. Yay, Miss Johnson. Okay, why do I want you to check your answer? Because the more you check your answer, the more confidence you have towards submitting this as a response and knowing that you did well on that equation. Does that make sense? The other way to do it is by using my best friend Desmos, right? So my best friend Desmos, I'm going to plug in this equation that I have right here. So you could put y equals -3 parentheses x plus 1 close parentheses minus 5, and I get this equation. So then I need to check, is -1, -5, is it on this line? Because if it's not, I don't like it. So cute. Okay, so I'm going to look for -1, -5. So I start here and I'm looking for -1. So here's -1 and wait, did I plug it in correctly? Okay, right? Did I do that right? -1, -5. Oh, this is not -1 because it's going up by 2, Miss Johnson. Miss Johnson, it's going up by 2s. Yes, ma'am. All right, so here I'm going to go down -1. I'm going to look. Oh, I hope it's this point right here. Oh, look, it keeps showing up. Sorry, I got to find the -1 guy. And of course, Miss Johnson can't find it perfectly. I can't find it perfectly. Hold on. Okay, well, you get the point. Someone help me. My mouse is too like movie. It shut up for a second. Okay, here. All right. I'm just gonna say, of course, there it is. Yay, look, it's right there. Everyone look, because if I let go of my mouse, it's gonna move. Very good. So this is the point that they gave me, -1, -5. And then they also gave us a slope of -3. So I'm going to show you where I see my slope as -3 by drawing arrows on top of this guy. So here we go. So I'm going to find me a good point. This guy is really good. So I'm going to use this guy. And then I also see that this guy is a really good point. So I'm going to go up this much, right? And then over this much, right? So this happens to be, sorry, I'm annotating on top of Zoom, so it's not going to be very neat. So this guy is a +3, right? And this is a 1, except for because we went to the left one. What does left mean in math? What does left mean in math? Yeah, negative. Very good. Perfect. Oh, I'm so excited. Okay, so that means my slope, my m would, I'm not going to annotate on here, but my m would be 3 over -1, which we all know as -3. So that's how I'm checking my answer. Okay, so let me put this away for a second. Oops, I'm still in annotation mode. Here we go. Okay, so that's how I would check my answer. Okay. So Zach says, Zach has a challenge. I'll bet you can't use this pattern to write the equation of a line through here. Yes, ma'am. Yes, ma'am. So Zach has a challenge. So how would you do this first? Can you like brainstorm with me really quick? How would you do this problem? If my goal is to write it in point slope form, did they give me a point? Did they give me a point? Everyone says, yeah, they give me a point. Very good. Okay. So they give me a point, check. So remember, if I'm going to build, if you want me to make you a quesadilla, I hope that I have a tortilla and cheese, right? If I don't, then I can't make you a quesadilla, right? And butter. Yes. Butter is the obvious, or oil, or some kind of something that'll make it happy in there. Okay. So they gave me a point. Yay. Okay. But what did they not give me? Dun, dun, dun. But can I write the equation given the ingredients that you gave me? Can I still write it? Everyone says yes. So very good. So I want you to try this one on your own. If you're stuck a little bit, someone just said cheese is slope. Oh my goodness. Okay. So the answer is yes, you can do that. Yes, you can. So yes, you can. So first you would have to do something, and then you can plug everybody in here. So take everyone pencil to paper. Go ahead. Okay, so what was the deal? What did you guys do first? What did you have to do first? Or actually, you didn't have to do first, but what did you have to find first? Yes, you had to find the slope. Oh, they didn't give me the slope. So here's your options on finding slope. Either 1, calculate, 2, graph it, and then count it. It's up to you. So the very first thing I'm going to do is find my slope. So I go m equals 2, and then this is how I find slope. I put a little like minus over minus. You'll see it appear here. So that way I don't get my minuses mixed up with the negatives of the actual number. And as soon as this shows up, here we go. Come on, buddy. Excuse me. Ooh, excuse me.
That's you.
Thanks. Okay, so here it goes. M equals to minus over minus. This is how I started. And then I start filling everybody in. So then I take a y. So I'm going to take that -3. And then I put his x underneath. I put the 1 underneath it. So these guys are pairs. I take -5. And then some people get confused. They're like, Ms. Johnson, is that negative? That negative? No, it's not. That's a minus and that's a negative. And then I put a 3 on the bottom, and then I just calculate. So I clean this up. So -3 plus 5 is 2, divided by -2 is -1. So my slope was -1. Is that what you guys got? Good. Okay, very good. So then I write my equation again, and then I'm like, oh, did I write it correctly? And I'm like, yeah, I did. Okay, and then I'm going to choose a point. Now, it doesn't matter. I don't know. Yeah, I know, right? Wait, you don't know which one is y1 or y2. It doesn't matter. You can go -3 minus -5, or you can do -5 minus -3. As long as your x's match up and down with their y's, then they're fine. So these match and these match, and then you're fine. So here, I don't know which point I want to use. Now, if you used one point and I'm using the other, our equations won't look the same, but they are equivalent, right? They are equivalent. Okay, so it's just like a $20 bill and 2 $10 bills. They're equivalent, but they don't look the same. Okay, so here we're gonna write y equals blank parentheses x minus blank plus blank. Okay. And then I'm going to throw everybody in where they go. So I got -1 as my slope. And then I'm going to choose the first point just because it's first. So x minus 1 and then plus -3. And then I'm just going to clean everybody up. So I kind of don't like writing -1. I just like writing a negative. So y equals to negative parentheses x minus 1, close parentheses, -3. There's my answer. I've already told you how to check it, so we should be good on that. And then you can actually, I would check it using the other point that they gave me, right? So 3 minus 1 is 2, negative of 2 is -2, minus 3 is -5. Yay! Right, so there you go. Yeah, it is actually -1. The slope is -1. Because if I graph 1, -3, so here's my little mini graph. Actually, I'll graph it up here just so that you guys can see the slope. So 1, -3 is down here, right? And then 3, -5. 3, -5 is right here. 3, oops, I didn't count right, sorry. Okay, so 3, -5 is right there. And then if you look at your slope, it's, oops, I'm in erase mode. So if I look at my slope, it's up 2, left 2, so 2, -2. So that's my slope, it's negative. So if I look at that line, the slope of that line is negative. The way I know it's negative is because if I am on a roller coaster from left to right, I'm going down the hill as opposed to up the hill, right? Very good. All right, just a couple more here. So Sion is still thinking about the pattern. I wonder if we could use the pattern to graph lines, thinking of the starting point and using slope. What? I didn't understand that. Sion is still thinking about the pattern. I wonder if we could use this pattern to graph lines. Oh, I understand. Thinking of the starting point and then start thinking of that starting point and then using the slope. Try it with this equation. So you guys know how to graph from y equals mx plus b. She's wondering, can we graph from here? And so I'm going to pull this guy down here. So y equals -2 parentheses x plus 1 close -3. And the very first thing that I want to do is I want to draw axes, and I like drawing axes because they're a little bit more straighter. So what color am I doing here? So it might not snap into place. So just kind of be, oh, that's pretty good. So it's not going to necessarily be in the middle, nor does it have to. I will try to make it in the middle. Nope, that's not in the middle. It's okay. So let me try to move them up or down. Yeah, that's pretty good. That's better. All right, so I have axes here. Here's your x-axis, here's your y-axis. So here's what they're saying. Can I graph from here? Yeah, so you got to tell me first. Okay, well, what's the starting point? So can you peel off the slope and can you peel off my my starting point here? So the slope, you guys could all see it. Very good. It's -2. Thanks for that help there. What is my starting point? Now be careful. Look, here's your equation, right? Yeah, it's -1, -3, right? It's the point -1, -3. Now, if you thought that the point was 1, I understand why you thought that. But remember, it's x minus x1, it's x minus x1. So that number in there you need to take his opposite. The way I talk about it in my integrated 2 and 3 classes is x is always backwards. He always lives in like opposite land, backwards land. Do you guys remember doing that? Like whatever you say, no matter what, I'm going to say the opposite, backward, upside down, like opposite day. Remember? No? Like if I say yes, I really mean no kind of thing. So x is opposite. So if you see +1, it's really -1. Oh, no, not in math class, just as a little kid. As a little kid. Like, didn't you guys ever do like opposite day? Yeah. So x lives in opposite day. He doesn't follow directions very well. So if you see +1, right, then it's -1. So I'm going to start by plotting the point -1, -3. So I go left 1 up 3. No, sorry, left 1 down 3. Left 1 down 3. And then I'm going to use the slope to get to my next point. So my slope, I like writing my slope as a fraction. That way it's giving me direction, go down to right one. So I'm going to go down to right one, down to right one. So I could either go down to right one, or I can go, because -2 divided by 1 is the same as 2 divided by -1. Do you guys all see that? Do you think that this is true? -2 divided by 1 is equal to 2 divided by -1, right? So from there, I could even go up to left one, up to left one. And do you guys all see my line there? Does everybody see that line? And then if I was really fancy, I would make a line. So let me make my line. I can't see if I can do this. Oh, look at me. I so fancy. Okay, so there's my line. Okay. So Zach wonders, what is it about lines that make all this work? How would you answer, Zach? How would you answer how we were able to graph this using point slope form versus using the other one? How were we able to do that? So in order to build a line, what do you need? I guess is the question. Yeah, you only need a slope and a point. Now, y equals mx plus b. Some of you are like, but he's my favorite. That's fine. B is still a point. It's just a very specific point, right? He's just a very specific point. Good job. All right.